So we're going to cover standard error. So this is, you asked, is there a magic number for sample size? No, but this is going to help. If we're looking at standard error, it's very similar to standard deviation. So we learned that last week. It looks at the spread of your data. So how far apart of your data points on average. So standard error, when you have standard deviation, it's supposed to be of the population. So if you have the whole population, for instance, the prescribing rates. All right, yes, okay. So the standard error is related to a sample. So if you have all 612 prescribing rates, then you don't need a standard error. The standard error is used for samples, and I'll explain why and how it's different and when I pull up the formula. But that's the basic difference between the two. You basically have to adjust for not knowing everything. So this is why. Okay, so standard deviation, again, is of the population. So the reason when you have high standard errors, that's a red flag no matter what. This is usually, you can do standard error of the mean. Every statistical test except for machine learning test will also output a standard error. If it's really, really high, then you have a sample size problem, more than likely. If it's really, really low, then you're good to go. But what this means is we're taking very similar, we have that standard deviation value, then we're dividing by the square root of the sample size. So all that's really doing is normalizing or adjusting for your sample size. So by default, if you have a sample size of 10,000, that square root of n is going to create the standard error will be lower because you're dividing by a larger number. If you only have 100 observations, it's going to be higher. And that is why it can be a red flag for sample size issues. And that is just to adjust when you don't have all the information. You need that standard error value, and it's used for other things, and I'm going to get to that. We're going to cover confidence intervals today, or at least I'm going to try to get there. If we don't, we'll do it next week. But that's the basic idea. Higher is bad, smaller is good. It looks at the distribution, and then it adjusts for your sample size. This is basically going to tell you, honestly, a lot of it's how reliable your things that you're outputting. In case I'm going to show it with me in a minute, but that's the major thing it's used for, is looking at spread and then but for the most part, looking for red flags. Because when you see something high, and say you're running a t-test, it's a statistical test we'll cover, it's the most simple one. If you see a standard error that is gigantic in that, then your results mean nothing.